This question is about an electric car, which I'll just represent with this box here. And we want to know what the air resistance, the drag, which we'll call D, is acting on that car. Now there must be, since it's travelling at a constant velocity of 36 kilometers an hour, there must be a driving force which is acting in the opposite direction to counteract that drag, and we'll call that force F. So really that's the force we're trying to find here, what force is being supplied by the engine. Now at first glance we're not being given enough information to find that out. We've got the voltage and the current, we've got the speed, but to work out the force we would need to involve work done. So let's think about it in a slightly different way. Let's use the information we've got. So let's work out the power that is coming out of the electric car. So that power equals voltage times current, which equals here 160 times 100. So our power equals 16,000 watts. Okay, so we've now got a power of 16,000 watts. One thing to note here is that our velocity is in a non-SI unit of kilometers per hour, so let's convert that to meters per second. So V equals 36 kilometers per hour, which is going to be the same as saying 36,000 meters per hour. Still not an SI unit, so we need to divide 36,000 by the number of seconds in an hour, which is 3,600, that's 60 squared, to give us an answer in meters per second, which we'll find is actually 10 meters per second. Okay, so we've got some numbers to work with now. Now, if we want to work out the force, one way of doing that is to think about the work done. So we can say that work done, W equals F times D, the force times the distance moved in the direction of the force. Now again, we don't know D and we don't know work done here, but we do know the power, and power equals work done divided by time. So let's see if that helps us. So power equals work done divided by time. If we divided the work done by time, let's also divide FD by the time. And now we can spot that we have D over T here. Distance divided by time is speed, so we can say that this becomes F times V. So we now have an equation, P equals FV, which we can neatly rearrange to F equals P divided by V, which will give us 16,000 divided by 10, so 1,600 newtons, which is answer B up here. An alternative way of looking at this question could be just to take a snapshot of 1 second. So you know the velocity of the car, you know the power of the car at 100% efficiency. So you can just say that in 1 second it's going to use 16,000 joules of energy, and you can say that in 1 second it will travel 10 meters. So then you would have a more straightforward question of having work done, force and distance, if you'd prefer to do that rather than working with time.